Hello everyone, and thank you for joining us today as we discuss the challenges that Dell Technologies had to overcome during the 2020 superconductor shortages. Dell Technologies is one of the most recognizable names in global technology manufacturing and distribution. Founded by Michael Dell, the company's model emphasizes direct engagement with customers, enabling customized production and efficient delivery. This approach has long required a finely tuned global supply chain. Dell's reputation for operational excellence is tied directly to its ability to manage component sourcing, especially semiconductors, which are vital to almost all of its product lines. Every laptop, desktop, and data server Dell produces requires microchips that manage computing power, data processing, and energy control. Semiconductors enable Dell systems to deliver speed, efficiency, and connectivity to both individual consumers and enterprise clients. Without a steady, reliable semiconductor supply, Dell's manufacturing, innovation cycles, and ability to meet customer demand would come to a halt. Because of this, semiconductor procurement and management are central to Dell's operational strategy, influencing product design, production scheduling, and overall supply chain resilience. Semiconductors form the foundation of Dell's operations because they drive the core functionality of every device the company manufactures. These microchips process data, manage memory, and enable system connectivity. To ensure a steady and innovative component supply, Dell maintains strategic relationships with leading chip makers such as Intel, AMD, NVIDIA, Broadcom, and Qualcomm. Each provides specialized technologies that support Dell's product diversity. The graph on this slide illustrates Dell's relative partnership strength with each supplier, showing how deeply integrated Intel and AMD remain in Dell's PC and server product lines, while NVIDIA plays a growing role in graphics and AI-driven solutions. These alliances are critical for Dell's supply chain continuity and its capacity to adapt to evolving technological demands. The semiconductor shortage became one of the most significant supply chain disruptions in modern manufacturing history. When the COVID-19 pandemic hit, factories in Asia temporarily shut down to protect workers, while global demand for electronics exploded as consumers and corporations rushed to purchase laptops, monitors, and servers to support remote work and learning. This created a situation where supply was constrained just as demand surged. For Dell, the impact was immediate. The company's just-in-time manufacturing model, which relies on synchronized deliveries of components to minimize inventory costs, suddenly became unsustainable. Lead times for some semiconductors rose from weeks to nearly a year, forcing Dell to delay or reprioritize production schedules. Some consumer and enterprise customers experienced significant delays, reducing Dell's ability to meet demand at a time when market opportunities were high. This crisis highlighted a structural issue across the technology industry. Efficiency-driven systems lack flexibility when facing large-scale disruptions. This shortage forced Dell and other manufacturers to rethink their balance between efficiency and resilience, paving the way for strategic supply chain reforms in subsequent years. The root of the semiconductor crisis can be traced to a convergence of global factors. The pandemic initially halted production at major fabrication plants in Asia, the region that produces nearly 80% of the world's chips. At the same time, demand for electronics soared as consumers and corporations invested in technology to support remote operations. This imbalance created a bottleneck that rippled across every link of the supply chain. Dell, like many other tech manufacturers, relied on just-in-time systems to maintain lean inventories. While this model improved efficiency under normal conditions, it became a liability when supplier capacity fell and transportation slowed. Shipping container shortages and congested ports further restricted the flow of critical materials. The result was a cascading shortage that reduced Dell's ability to meet production targets, delayed order fulfillment, and forced the company to re-examine how its operational model could withstand global disruptions. The semiconductor shortage not only created short-term supply and cost challenges, but also triggered deeper operational reflection within Dell Technologies. As production delays mounted and costs increased, Dell recognized that its traditional efficiency-focused systems were no longer sustainable in this environment. The company's immediate actions, such as supplier diversification and predictive modeling, provided short-term relief. However, the true test lay in reevaluating how its foundational build-to-order model functioned under stress. We will now dive into an examination of how the shortage directly disrupted Dell's core operations and how the company's model, designed for speed and customization, became vulnerable under systemic shocks. The semiconductor shortage was a global systemic shock that constrained Dell's upstream supply. As a result, lead times for critical parts increased from weeks to months, affecting assembly schedules. Dell operates a just-in-time build-to-order model. The shortage caused component bottlenecks that disrupted Dell's production and delivery operations. Dell's build-to-order model is highly efficient under stable conditions, but during the chip shortage, this efficiency was eliminated. Without contingency plans in place, Dell was forced to shift production towards its most profitable product lines, which created ripple effects throughout the downstream supply chain. Dell's manufacturing and planning functions were forced to shift from forecast-driven to allocation-driven scheduling. The shortage highlighted the need for greater visibility across multi-tier suppliers and better contingency planning, which are key risk mitigation concepts. When the chip shortage hit, Dell moved fast. The company built a global task force that worked across manufacturing, procurement, and logistics to stay on top of the situation. That met daily to monitor supplier capacity and reused real-time data to shift production towards the most in-demand products, especially servers and premium laptops. By tightening communication in suppliers like Intel and AMD, Dell was able to stay flexible and keep essential products flowing even when parts were limited. Dell made flexibility a core strategy. Instead of relying on a single supplier or region, they diversified their sourcing and spread production across different global hubs. When one site faced shortages or shipping delays, production could shift elsewhere. Dell also built shared component inventories so that plants could draw from common stock when shortages occurred. This approach helped them keep production steady and avoid long shutdowns that competitors faced. Dell did not wait for supply conditions to settle down. Instead, they built a system that could shift and adapt every week. Teams reviewed live supplier data and updated production schedules in real time, sometimes several times a month, to match actual chip availability. They also reworked supplier contracts to include flexibility clauses, so Dell could scale orders up or down as needed. To avoid bottlenecks, the company added backup suppliers and approved alternate chipsets, which kept production running even when one source fell short. This adaptive planning allowed Dell to stay ahead of disruptions rather than scrambling to recover. Their approach combined three key elements. Dell used multi-supplier sourcing and global manufacturing flexibility to balance component flow across regions. They fine-tuned production priorities, focused on critical SKUs, and maintained alternative sourcing paths to support contingency planning. Finally, a global task force coordinated chip allocation and ensured transparency and fairness across customer groups, demonstrating Dell's strong crisis management response. During the height of the shortage, Dell's crisis teams met daily to make fast calls about where limited chips should go. They used dashboards that tracked supply levels and shipping routes in real time. At the same time, Dell kept customers in the loop, especially large enterprise clients, by being upfront about lead times and delivery changes. That transparency built trust and gave customers confidence that Dell was managing the problem directly instead of hiding behind delays. In the end, Dell came out stronger. They managed to maintain shorter delivery times than most competitors, even at the peak of the shortage. The close relationships they built with suppliers led to better forecasting and shared visibility across the chain. Dell also made long-term changes by implementing more regional manufacturing, better analytics, and smarter planning, so now they could be prepared for the next global disruption. What started as a crisis ended up reshaping how Dell runs its supply chain for the future. The resilience frameworks introduced in class highlight risk mitigation as the first step in preparing for disruption. Dell strengthened its risk position by mapping suppliers across tiers, monitoring production status, and using predictive analytics to anticipate bottlenecks. The company also diversified its sourcing base, ensuring that production could continue even if one region experienced shortages. This proactive approach reflects a key principle from our learning. Long-term resilience depends on early visibility and balanced planning. From the SCOR's framework's plan stage, aggregate planning involves matching supply capabilities to anticipated demand while minimizing disruptions. Dell applied this approach during the semiconductor shortage by realigning production plans to the pace of chip deliveries. Through close coordination with suppliers and advanced forecasting, Dell could prioritize high-demand and high-margin products, adjusting build schedules weekly instead of quarterly. This strategic alignment between planning and execution helped Dell maintain operational stability even as global chip lead times extended. Aggregate planning allowed Dell to remain agile, ensuring that available semiconductor capacity was used efficiently without overcommitting production. The bullwhip effect, as described in our learning on supply chain coordination, occurs when small changes in customer demand lead to increasingly large fluctuations in orders upstream. During the semiconductor shortage, Dell experienced this phenomenon as suppliers reacted to inconsistent order patterns, leading to excess demand signals and component imbalances. To counter this, Dell enhanced real-time information sharing with both Tier 1 and Tier 2 suppliers. Using digital dashboards and integrated planning tools, Dell synchronized demand forecasts with actual customer data, reducing the amplification of misinformation across its network. By curbing the bullwhip effect, Dell achieved steadier production rates, avoided overstocking low-demand components, and maintained tighter alignment between real demand and supplier output. This demonstrates how effective coordination and transparency can transform a volatile supply network into a more predictable and stable system, even under global shortages. The concept of market-responsive supply chain design, as outlined in our coordination learning materials, aligns with Dell's model as a technology manufacturer with rapid product turnover. During the chip shortage, Dell needed to respond quickly to unpredictable supply fluctuations while continuing to meet customer expectations for delivery speed. Instead of relying solely on distant manufacturing sites, Dell leveraged regional assembly hubs, such as facilities in the US and Asia, to reduce shipping times and increase responsiveness. By aligning production decisions with current market demand data, Dell enhanced its agility, reducing excess inventory, and ensuring chips went into the most time-sensitive products. From the coordination concepts we studied, supplier collaboration and visibility play a critical role in reducing information silos. Dell strengthened supplier integration by sharing demand forecasts and production schedules directly through digital platforms. This visibility enabled upstream partners to anticipate Dell's component needs, allowing better planning and timely delivery. Dell also entered long-term strategic partnerships with key semiconductor producers to ensure access to the limited chip supply. This high level of collaboration not only stabilized Dell's operations during the shortage, but also reinforced trust and alignment throughout the supply network. From our learning on inventory management, maintaining safety inventory helps protect against unpredictable supply or demand changes. Dell used this strategy selectively, holding extra stock of key semiconductors that had the most constrained production schedules. This was not traditional overstocking, but a calculated buffer built on data-driven analysis of component risk and delivery delays. The buffer inventory ensured that critical production lines, especially for business and enterprise systems, continued without significant interruptions. This decision reflects a well-managed trade-off between additional holding costs and the greater value of uninterrupted operations during a global supply disruption. The tech industry relies heavily on semiconductors for producing laptops, smart devices, servers, and other hardware. The surge in demand during the COVID-19 pandemic put enormous pressure on supply. The shortage affected companies of all sizes, including HP, Apple, Lenovo, and Microsoft. Extended lead times and constrained production became common across the industry, highlighting how vulnerable the tech supply chain is when a critical component becomes scarce. This context helps us understand why companies need to respond quickly and adapt their operations to maintain service levels and market competitiveness. Now, let's take a look at how the shortage impacted major tech competitors. Apple, for example, had a slow production for iPads and certain Mac models due to limits on chip allocations. This affected product availability for customers and delayed some launch timelines. HP faced similar challenges. Inventory shortages for PC components restricted their ability to fulfill orders, which created backlogs and impacted revenue. Lenovo also experienced constrained supply that reduced their shipment volumes and affected market share. It's important to note that these challenges were not isolated to technology. Automotive and consumer electronics industries were also competing for the same limited chip supply. This cross-industry demand made it even more difficult for companies to secure the components they needed. By examining these examples, we can see the broader industry pressures that force companies to rethink their supply chain strategies. Given these challenges, tech firms implemented a variety of strategies to increase supply chain resilience. One key approach was multi-sourcing and reducing dependence on a single semiconductor supplier. Long-term contracts and advanced purchasing agreements were also used to secure chip allocations in advance. Companies increased inventory buffering of critical components to absorb fluctuations in supply. In addition, there was a stronger emphasis on forecasting and collaboration with suppliers, enabling greater visibility and better planning. These strategies align closely with the resilience concepts from our lecture notes, including risk mitigation, contingency planning, and flexibility. By adopting these proactive measures, companies position themselves to respond faster to ongoing supply disruptions. Let's take a look at some real-world examples. Apple invested in long-term semiconductor contracts and prioritized production of high-margin products, allowing them to maintain availability of their most important devices. Microsoft diversified its suppliers for Xbox chips, ensuring more stable production capacity. HP enhanced communication with suppliers and adjusted product configurations to maintain output despite shortages. We also saw an industry shift towards regional manufacturing and nearshoring. These examples illustrate that while strategies vary depending on each company's business model, there is a common goal: to maintain service levels and minimize disruption. Firms that were proactive in building visibility, flexibility, and supplier collaboration were able to navigate the shortage more effectively than those relying on reactive measures. There are several key lessons from these cases. First, visibility and early warning systems are critical to detect and respond to supply chain disruptions. Second, scenario planning and contingency playbooks enable companies to react quickly when shortages occur. Third, supplier collaboration is a long-term investment rather than a response used only during crises. Ultimately, resilient supply chains require proactive design. Companies that implement multi-sourcing, advanced purchasing, flexible inventory management, and strong supplier relationships are better prepared for future disruptions. The semiconductor shortage is a clear example of why firms need to invest in resilience before problems arise, rather than waiting to react after the fact. I want to thank you all for listening to our presentation on Dell's response to the COVID semiconductor shortage. Goodbye for now.